Okay, today we're going to talk about the graphs of the sine and cosine function. We'll start moving them around a bit, but basically we're just getting down what it looks like, the basic graph of that sine and cosine function. Before we begin, let's go ahead and do the bell work question. If you haven't done it, maybe pause, try it, and then try to see the answer. All right, sine alpha, we're supposed to find sine alpha given that cosine alpha equals 3 over 5, and alpha is in quadrant 1. Remember, the whole point of me telling what quadrant it is to decide whether it's positive or negative at the end of the day. Well, in quadrant 1, we don't have to worry much because they're both positive. It is that all, from all students take calculus, is that all part, so they're both positive. All right, now remember our trig identity is basically cosine squared plus sine squared equals 1. But we know that cosine equals that 3 over 5. So instead of putting cosine squared, I'm just going to put that 3 over 5 right off the bat. So we have a 3 over 5 squared plus sine squared needs to equal, let's put our alpha in there, is going to equal 1. Well, 3 over 5 squared is actually 9 over 25 plus that sine squared alpha equals 1. Now what I'm going to do is I'm going to subtract that 9 over 25. So a little hint here is I know that this base is 25, so I won't even write 1. I usually just write 25 over 25. That way in my head I can simply think about, well, I'm subtracting 9 over 25 from both sides. I can do that in my head pretty quickly because it's just 25 minus 9. So anyway, we're going to get up to our sine squared alpha is going to equal 16 over 25. Then we're going to take the square root of both sides. Let's do that in red, saying we're doing that. Remember, it is plus or minus. I kind of didn't leave room for it, but we can see it there. It's plus or minus square root of 16 over 25. But we really don't have to worry about the plus or minus because we know our answer needs to be plus. So we're going to end up with sine squared alpha. If you take the square root of it, you're just left with sine alpha. And you're going to be left with a positive 4 over 5. So our correct answer is a positive 4 over 5. All right, let's get into our graphing. The very first thing we're going to do is we're going to do our basic graph of our sine. Now, the very first time you ever graphed anything, say y equals x squared, y equals x, you generally plotted points to get an idea what it looks like. So that's exactly what we're going to do. We're going to go ahead and use our unit circle to come up with these really big numbers for graphing. And that is our key 0 degrees, pi over 2, pi, 3 pi over 2, and 2 pi. Because if you look at all your sine and cosine values, they're basically bouncing between 0 and negative 1 and positive 1. Nothing gets bigger than positive 1, and nothing gets smaller than a negative 1. So looking at those 5 points, we're able to get the entire graph of our sine function. So what I mean by that is we're actually going to find the sine of 0. Note, not 0 degrees, but 0 radians. And that's just going to equal 0. Now the sine of pi over 2, that's the one that's straight up. If we look at our unit circle, that's going to be 1. Then we look at our sine of pi, which equals 0. The sine of 3 pi over 2, that's going to equal a negative 1. And finally, sine of 2 pi is back to 0. Now if you notice on the graph of the right to this, it goes between 1 and a negative 1 for our y values. Well, that's going to be these values right here. All right, our x values are what we input, our y values are what we get out. So when I inputted 0, which is right here, we get out 0. So we're going to use the point 0, 0. That will be our starting off point. Our next input is pi over 2, and that results in 1. Okay, well that means we need to write pi over 2 down next. So we're going to write our pi over 2, and that goes all the way up to 1. The next point we used was pi. We inputted pi right here, which resulted in 0. So we're going to write pi, and that's at 0. Our next one we inputted was 3 pi over 2. That was negative 1. And finally we inputted 2 pi. So we're at 2 pi, and that was at 0. Now, when I ask you to graph this, I don't want you to connect straight lines. That isn't how the unit circle works. The unit circle is a circle, So we're going to kind of make this mapped out as if a circle was rolling on top of it. So what we're going to do is we're actually going to make an arc, just like that. And you can kind of picture, excuse me, if I swap this around, we would have kind of a circular shape. Kind of oval because of the design of our graph, but it's more or less a circle. All right, so that's our graph. The first thing I want to talk about is, if you remember from all the work we've done, we can find other angles that are bigger than 2 pi. We can find other angles that are smaller than 0. For instance, I could plug in sine of 3 pi. If I plug in sine of 3 pi, I'm going to end up getting 0 out. So we can plug in all these big numbers and all these small numbers. So although most of the time we just draw our sine graph to look exactly like this, we should have an idea that it actually continues. It continues in both directions forever. And we can see that graph on the other side when we get to it, but you're going to see this graph just kind of goes around and around and around and around. Just like if I graph y equals x squared, it goes forever up. This goes forever left and right, continuous in this bouncing motion. So it's important to understand that. Okay, I do want to focus on these kind of definitions down here. A little clear image would be right here. So we have a sinusoidal axis, and that is a line that runs along the middle of the graph. Now, the sinusoidal axis, if I don't shift this graph up or down, is going to be this one right here. You can't quite see it because it's covered up, so I'm going to highlight it with a dashed line. Now it goes smack dab in the middle. Half the graph's above it, half it's below it. That is your sinusoidal axis. Axis. All right. The next thing I want to point out is it talks about amplitude. It says the amplitude is the distance between the sinusoidal axis and the max or the min. So your amplitude is basically how high does your graph go or how low does it go. But it's not the total height. Instead, your amplitude, what you're going to measure from is the highest point. Let's highlight this in red. It's the highest point to that halfway point. So if you look at that distance right now, that is 1. So the amplitude for this graph equals 1. In fact, I'm going to go ahead and write that off to the side because that is important. Our amplitude is 1. So the total distance from the top to the very bottom of the graph is actually 2. So that total distance I'm talking about is this distance here. The total distance is 2. Your amplitude is half that. So your amplitude is always half that total distance from your highest to lowest point. In other words, just look at that halfway point. How high does it get up to the top then? So it's half our total distance, or in other words, your highest point to your sinusoidal axis, which should be the same thing as your lowest point to your sinusoidal axis, which is also an amplitude of 1. All right. The next thing we talk about, one thing about this is important. Your amplitude, always positive. It's a distance. Always positive. Cool. All right. The next thing we have is something called the period. So that's the last definition I have down here. The period is the length of a complete cycle. So I said the graph continues forever, but what I just graphed here is one complete cycle. So from 0 to 2 pi, all of these numbers are just one flow. As soon as we get past 2 pi, it starts repeating itself. It would start repeating itself, repeating itself, repeating itself. So the period is how long it takes to get one full cycle in before it starts repeating itself. So your period is going to be right here. And that period length of this case is from 0 to 2 pi, so the length is actually 2 pi. So our period is 2 pi. Once again, your period is just one cycle. The cool thing about today is we're not doing too much manipulation of the graph, so our period is going to be always 2 pi today. When moving forward, we're going to change it a little bit, but for today, our period is always going to be 2 pi. That is our starting off point, that it takes 2 pi to complete a complete cycle. All right, let's go ahead and look at the cosine graph. So our cosine graph, we're going to do the exact same thing with those exact same points. We are going to find the cosine of 0. We are going to find the cosine of pi over 2. We're going to find the cosine of pi. We're going to find the cosine of 3 pi over 2. We're going to find our cosine of 2 pi. All right, these values are good to know. Just knowing them off the bat makes your life a little easier. You can also use your sine values, because if your sine is 0, your cosine is 1. If your sine is 1, your cosine is 0, so on and so forth. But let's go ahead and write these down. The cosine of 0 is 1. Cosine of pi over 2 is straight up. That is at 0.01, so this is going to be 0. Cosine of pi, which is 180 degrees, which is the one straight across, is going to be that point -1, 0, so your cosine is -1. 3 pi over 2 is that one that's straight down, so that's 0, -1, so that means your cosine is 0. And our final point is that 1, 0, so we're back at 1. Once again, we're plotting this. I actually know what our x-axis is going to look like, so I plugged in pi over 2, pi, 3 pi over 2, and 2 pi. Like I said, today, these are going to stay the same. So you can fill those out immediately when I ask you to graph it, for the most part. All right, so we start, when I plug in 0, I get out 1. When I plug in pi over 2, I get out 0. When I plug in pi, I get out -1. 3 pi over 2, I get out 0. 2 pi, I get out 1. So our graph's going to look something like this. Remember, we are picturing it could continue forever, but we just have to do one cycle. All right, the cool thing about cosine is it's pretty much the same thing as sine, except it's shifted over. Sine starts at 0, 0. Cosine starts at 0, 1. Good thing to remember is keeping these two things straight. All right, so the first thing we're going to do is we're going to talk about our amplitude. Our amplitude is that highest point to that lowest point. So once again, I'm looking from that to the sinusoidal axis, not the lowest point. It'd be half from the lowest point. But we do our highest point to our sinusoidal axis, which is our halfway point. So our amplitude is going to be 1. And the period is till it starts repeating itself, which is once again 2 pi. So if I ask for the graph of cosine or sine, this is what I'm expecting. We don't even need those dashed lines on the side like I'm doing here. That is all I'm asking you to do, is that solid portion. There are times where I might ask for 2 cycles, in which case you would just have to kind of continue on until you get to that second cycle. But that doesn't happen very much. This is our primary graph of cosine. And this is our primary graph of our sine. All right, let's go ahead and manipulate these graphs just a little bit. So first, like I said, if you look here, this blue section right here is called our fundamental cycle. It is the graph I'm actually asking for every single time I ask for a sine or a cosine graph. Just that one period, that 2 pi function. That's what I'm looking for. But do keep in mind that it does continue forever and ever and ever and ever and ever. But all I care about is that one cycle, because I could do the rest from there. All right, let's talk about some transformations of our graphs. Graphs of this form, y equals a sine b times x minus c plus d, have changes in them as follows. Now, we're not going to go through all of them. So like I said, we have an a we can change, we have a b we can change, we can have a c we can change, and a d we're going to change. Today we're just talking about a and c. So we're just going to focus on that a and c. Note this says sine, but cosine works just the same. All right, let's talk about that a, that number that's out in front, very out in front. That's going to change your amplitude, or how high and low a graph goes. A negative a changes the amplitude and flips the graph. In fact, when I'm dealing with a graph like this, I'm always going to take care of the amplitude first. No matter how many shifts we have, I'm going to handle the amplitude first. So we are supposed to graph 3 sine x. Our amplitude is always going to be this number here. So it's our a value, it's 3. The period for today is always going to be 2 pi, which means on the bottom we can always write pi over 2, pi, 3 pi over 2, and 2 pi. All right, we'll learn a different way to do that tomorrow, I believe. I think we're going to change our periods on that, but today we're just going to use this constantly. That's a good way to start. All right, now what I'm going to do is I'm going to label the x-axis as 1, or I'm sorry, the y-axis is 1, 2, 3, negative 1, negative 2, negative 3. Now, a normal sine graph, what I'm going to do is I'm going to go ahead and put my normal sine graph. Let's do a light color. Our normal sine graph starts at 0, 0, goes up to 1, comes back down, goes back down to 0, or negative 1, and goes back there. You have to know this shape. You have to be able to graph it just as quick as I just did, if not quicker. All right, now I want us to focus on this amplitude right now. Right now our amplitude is 1. Well, it says that I need the amplitude to be 3. Well, all we need to do is pump up this amplitude. We need to pump up this amplitude to 3. So that would be 3 units. This would be an amplitude of 3, which means our new point is going way up to 3. Well, that's easy enough. We just go from 0 to whatever our amplitude says we're supposed to go up to. So we're going all the way up to 3. You still come back down to 0. And then you go back to negative 3, and you come back to 0. So our end graph is going to look something like that. That is our 3 sine x. All we're doing is we're stretching and grabbing it from both sides and pulling really hard until both ends go to 3. Because note, down here also has that same amplitude of 3. All right, our next one says do negative 2 cosine x. Now your amplitude, I said, was always positive. So your amplitude is actually a positive 2. It is always positive. Period, like I said, we're not doing anything to it, so it's still going to be 2 pi. So we can go ahead and come down here and write pi over 2, pi, 3 pi over 2, and 2 pi. Let's go ahead and do our normal cosine graph. Our normal cosine graph actually starts at 0, 1. So it'd be right here. Let me actually go ahead and label those. So we have a 1, 2, 3. I have a negative 1, negative 2, negative 3. All right, our cosine starts at 0, 1. Then it goes down to 0, comes to negative 1, comes back up to 0, and it comes back up here. So we're looking at something that looks like that. Once again, our amplitude, our current amplitude, would be this distance here, which is 1 right now. That's our amplitude of 1. Well, I'm supposed to have an amplitude of negative 2. Negative 2. So what that means is we're actually going to, let's see if I can do this in purple. We're going to go up to 2, but we're going to flip it. We're going to flip it down there, and that's going to give me that negative 2. Now, I'm going to put negative 2, but we should know the distance is 2. But negative 2 brings it down instead of up. Well, that means we can finish this just in the opposite direction. We come back up here. Instead of going down like we have right here, we're going to go up. And we're going to go up to 2. Back down to 0, and instead of up to 1, we're going to go down 2. So we flip all of these points, and our new graph is going to look something like this. My advice to you when graphing these is I always graph my regular one. I graph my cosine x, and then I graph my changes, negative 2 cosine x. A good idea is to, when you're graphing just your basic ones, do it lightly and just do tick marks. That way when I see the bolded one, when I'm grading it, I know exactly which one you think your answer is. It doesn't hurt either to actually highlight that that's my finished answer. All right, so that's amplitude. It stretches and it flips. The next thing we're going to talk about is that C value. That C value. The C value shifts the graph right if you have x minus c, and it shifts it left if it's x plus c. You're going to see there's a constant kind of thing. If it's in parentheses like this, it's always going to go kind of that opposite direction that you think it goes in. So x minus c goes right, x plus c goes left. In other words, what do I plug in to make it work? So if we're looking at this, I have sine of x plus pi over 2. That plus tells me it's actually going to go left. And that's because you need to plug in a negative pi over 2 to even that out to 0. So that negative pi over 2 makes it shift left. So let's check out our amplitude. Our amplitude is that number that's right in front of the graph. Well, that's just 1. Or in front of the statement, I should say, is 1. Period, I told you we're not changing today, so that's still 2 pi. And it's going to shift left pi over 2. Okay, already labeled the x-axis for you. We're going to go ahead and change this mark a little bit. I want this to be 1 and this to be negative 1. It's going to make our graph look a little better. All right, we're graphing sine. So I'm going to graph the very basic sine function, which starts at 0, 0, goes up, comes back down, all the way down, and back here. That is just my basic sine of x. Now, we need to finish this up. I don't have to change the amplitude. All I need to do is I need to shift it left. And all you're going to do is you're going to shift all of your points left pi over 2 units. So instead of 0, 0, we have negative pi over 2. Once we have that distance down, we're just going to shift them all that same distance. So once again, we're shifting everything left, left, and we are done. That is our new graph. That is our finished product. That is our sine of x plus pi over 2. Biggest mistake people make is they forget that positive is left and negative is right. All right, the last one we're going to do is we're going to go right pi over 6 units. Pi over 6 units. So once again, that negative tells me we're moving right. Amplitude is still 1 because we're looking at that number up front. Period, I said we're not changing today, so it's still 2 pi. And we're going to shift right pi over 6 units. Well, to shift something right pi over 6 units, let's go ahead and first graph regular sine. Once again, it's too high. I'm just going to change it to 1 and negative 1 down here just to make it a little more compact. All right, our regular sine, once again, is 0, up, down, down, middle. That's my regular sine graph. We need to move right pi over 6. However, I don't know how far pi over 6 is. So a good idea is to recognize that pi over 6 is one of our key things on the unit circle. It goes 0, pi over 6, pi over 4, pi over 3, and then pi over 2. So if I'm using one of these key things, knowing that information, it's going to look something like this. Pi over 6, pi over 4, and I'm going to use that pi over 3. That pi over 6 comes first. I'm not looking for super perfection, just something like that. And I'm just going to shift all of them over that little tick mark. All right, I'm not making everything perfect. I just know it's being shifted right that little bit. And that's what we got. All right, so today we learned how to do the sine and cosine graph. We learned how to change the amplitude. We showed how to change it left and right. The rest is up to you. Good luck on the homework. Make sure if you have any questions, you ask me or ask in class tomorrow.